Much of the energy coming from the sun hits the surface of our planet. The sun radiation hitting the Earth can produce about 10,000 times the power used by the entire world population. Sunlight performs many functions in our planet. Among the most relevant ones are keeping a relatively constant temperature on the Earth, purifying the water through distillation, giving life and fruits in plants, and, at the same time, purifying the atmosphere and providing food for all living things. Sunlight also steers the winds around, and winds, in turn, drag the clouds to the high places to start rivers flowing and maintaining a constant cycle of distillation and mineralization of water. Solar radiation, together with the movements of translation and rotation of the Earth, produces days and nights, as well as years. While all this is vital for us, humankind has become highly dependent on electricity. For many centuries, electricity was produced by burning fossil fuel. However, burning of fossil fuel results in large amounts of pollution, mainly to the atmosphere, and is highly detrimental to both health and ecology in general. This has become a serious problem, and the solution is being sought through the direct transformation of solar energy into electrical energy. This is achieved by solar panels, which convert solar energy into electrical energy without using any moving parts which could wear out. Solar panels are made up of small units called solar cells, usually made of silicon, a very cheap and abundant element. To build a solar cell, two silicon crystals are placed side by side as a sandwich. The outer surfaces of the crystals are attached to metal strips which act as electricity output contacts. The crystal sandwich is shown in the figure. One of the two crystals is of the type called negative. For short, it is called an N crystal. The crystal below it is of the positive type, P crystal for short. We can imagine sunlight as microscopic particles that stimulate the N crystal to produce negative charges called electrons, while stimulating the P crystal to generate positive charges, also known as holes. The electrons produced in the N crystals leave the crystalline structure through a metal strip shown in the upper part of the drawing. The holes produced in the P crystal sort of catch the negative particles into this crystal through the metal strip shown in the lower part of the drawing. While the circuit formed by the two crystals is closed, there is a flow of electric current that can be used to operate a motor, charge a battery, turn on a light bulb, or to operate a cell phone. The voltage produced by a single cell is very small, but you can hook many cells together in a solar panel and get an output powerful enough to operate high-power devices. By installing a system with several panels, we can supply all the electricity needed for a household. I hope this very simplified explanation has been useful to you. Thanks for watching, and please subscribe to my channel. Chava Tarin.